Welcome. Let's find the limit as x approaches 0 of the rational function here in the right. Well, if you want to find the limit at a location, let's start by evaluating the function at that location. Well, when we simplify this, we're going to get square root of 1 minus 1 divided by 0, 1 minus 1 divided by 0. So notice that we obtained the result of 0 divided by 0. So this does not mean that the limit does not exist. Anytime that we have a result of 0 divided by 0 after an evaluation, what we have to do, we have to simplify the expression and then we're going to evaluate it again. So let me erase our evaluation and now let's talk about how we can simplify the rational expression. Well, the denominator, there's nothing that we can do about it. It is just an expression. There's nothing to simplify there. But when I take a look at the numerator, I see that I have two terms. So let me try what happens when I multiply by the reciprocal of the numerator, top and bottom. And just in case you need a refresher, a reciprocal, it is the same expression, but we change the sign of the second term. So notice that we had a negative, and now we just change that sign to a positive. So let's start by multiplying the numerators. I see that there are two terms on the left and the right. So let's perform some FOIL. The square root of x plus 1 times the square root of x plus 1, that is just equivalent to x plus 1. Any square expression multiplied by itself, it is equal to just the inside of the square root. Let's just visualize that real quick. So the square root of x plus 1 times the square root of x plus 1. But this is nothing more than the square root of x plus 1 square. But now the square root will cancel out with the exponent, and now we just have x plus 1, which is the result that we have written here. Now let's distribute to the next term. The square root of x plus 1 times 1, well, that's just the square root of x plus 1. Now let's distribute the next term. Negative 1 times the square root of x plus 1, but that's just negative square root of x plus 1. And when we make the last distribution, negative 1 times 1, but that's just negative 1. Now on the denominator, let's just write down the multiplication that we would have gotten, which is x times the square root of x plus 1 plus 1. Let me not distribute that yet. We will see why in a second. Well, let's simplify our result. Well, the reason why we wanted to multiply by the negative reciprocal is because the terms in the middles, they will always cancel out, which is what we have here. So let's rewrite the simplified version. So on the numerator, we're going to get x plus 1, which is what's left, and then negative 1, which is the last term that is still left. And on the denominator, we have x times the square root of x plus 1 plus 1. But when I continue simplifying this, notice that the negative ones will cancel out as well. And now the numerator, it is just x. Let me rewrite the denominator. Notice that we can still simplify this a little bit further, because now the expression on the numerator, because we are multiplying, it cancels out with the expression of x in the denominator as well. And look at what we have at the end. The numerator, it is just the value of 1. And on the denominator, we have the square root of x plus 1 plus 1 on the outside. Now that we have simplified the expression, let's re-evaluate our function. And on the numerator, we got 1. And then we got the square root of 1 plus 1. We have 1 divided by 2. So we have a numerical result. So as a conclusion, we can say that when we take a look at the rational function of x plus 1 minus 1 divided by x, and we wanted to find the limit as x approaches 0, Well, that is equivalent to 1 over 2. Let's verify this result by finding the same limit, but now graphically. The graph in the right represents the rational that we were given. When we evaluate it at the x value of 0, we can see that we have an undefined value, but we knew that because remember that when we evaluate the function at 0, we obtain 0 over 0. So we know that we were expecting to have a hole in the graph. Let's actually do that. Even though we have a hole in the graph, the limit still exists because as I approach the value of x equals 0 from the left, it is the same destination as I approach x equals 0 from the right. And the value that we are approaching, it is the y value of 1/2, which is what we found algebraically when we went through the process of simplifying and re-evaluating our limit. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.